Good day everyone, I am Nasimah Rahim and I am going to present the progress of my research, and the title is In Silico Search for Potential Inhibitor of the Main Protease of SARS-CoV-2. My supervisor is Dr. Nurul Bahia binti Ahmad Karudin.
Severe acute respiratory or SARS-CoV-2 is known as the novel coronavirus or coronavirus disease 19, COVID-19 by the World Health Organization (WHO). It is very contagious and spreading so vigorously that belief have emerged from Wuhan market, where the virus spread from animals to human. It had caused several problems in terms of health, economy, and mental clarity even up to this day. The main protease that is applied in my FYP is the 3-chymotrypsin-like protease. The key protease is a large and desirable drug mainly to inhibit the development of non-viral component, eventually hinder the replication of the life cycle of the virus. The first origins of the virus remain unclear. The widespread of it across the community nationally have been verified. In my research, I emphasize on molecular docking, or also known as the in silico analysis, using Autodobina as the simulation tool for the binding of drugs with 3-chymotrypsin-like protease, which is the viral protein. The focus of my study is the path taken for the battle of potential drugs and prevention of the spreading of the virus that attacks the spike protein of COVID-19, as there is no drug available to cure COVID-19 yet. The objective of this study is to predict the potential drug candidate for the treatments of COVID-19 by investigating the binding mechanism and molecular interaction of bleomycin, mitramycin, and gosrelin with 3-chymotrypsin-like protease of coronavirus 3CL-Pro using molecular docking simulation approach. To meet the objective of this study, the following scopes need to be considered. The COVID-19 receptor used in this study was 3-chymotrypsin-like protease 3CL-Pro, and the drugs were selected randomly. The complexes of 3-chymotrypsin-like protease 3CL-Pro and drugs were obtained from molecular docking methods. The selection of the best 9 complexes was based on the lowest energy conformation. The binding modes between the potential drug and the receptor will be investigated by looking at the molecular interaction such as hydrogen bonding, hydrophobic interaction, and electronic interactions. The methods of this research comprise of several important steps such as receptor preparation, ligand preparation, and lastly the molecular docking process using Autodobina. Protein structure of 3-chymotrypsin-like protease 3CL-Pro in the 3-dimensional structure was downloaded from protein database PDB in PDB format. Autodoc tools version 1.12 was also downloaded. In the Autodoc tools, all of the water and ligands were removed from the receptor and polar hydrogen together with column charges were added to it. Then the system was saved as a PDB Qt file in a separated 3 folder. The protein structure was downloaded and the structure is viewed in the Autodoc Tools software. The structure of the 3CL-Pro that was taken from PDB website was converted in Autodoc Tools application. Drugs such as bleomycin, mitramycin, and gosrelin structure was downloaded from PubChem database in 3D structure and was saved in SDF format. Polymer visualization tools were used to convert the file type from SDF to PDB format that was downloaded earlier to be used in Autodoc Tools. The ligand file was saved in Autodoc Tools as the PDB format to be viewed later. All of the structures of the ligands were prepared and saved in PDB Qt file folder separately to ease the docking process. Autodoc Tools firstly converted the PDB Qt format into the file input by docking procedure. Bleomycin drug usually prescribed to treat cancer patients. It can delay or prevent the production of cancer cells in the body. This may work to help alleviate fluid around the lungs caused by cancer. Mitramycin, or also known as plicamycin, a commonly used type of anti-cancer medication due to its ability to curb testicular neoplasm and reduces the calcium content. Goserelin drug, which is an alternative to radiation therapy and other drugs used in conjunction to treat localized prostate cancer. For all docking simulation, Autodoc Vena software was used with the improved system as the target for docking, whereby the ligands used were bleomycin, mitramycin, and goserelin. The binding energy between 3CL Pro and the ligands in the docking were observed and recorded. The grid and config file created first, then only the interaction between the ligands and the receptor were recorded in Autodoc Vena with certain commands. It is a crucial step before running the Autodoc Vena since the software doesn't have interface. The 3 input file were saved on the desktop in a separate folder for a separate docking process. These steps was repeated for all the ligands and are saved in the respective folder. Then the output file for all the 3 molecular interactions was screenshotted and saved in a separate folder. However, the output is only for the ligand position. The complexes can be seen either using PyMol molecular viewer or other application by first opening the protein file, later the output file to see the dock complexes. Those interactions were screenshotted and saved in the folder as docking 1, 2, and 3 on the desktop of the computer. There is a measurement of docking complexes that is named as the binding energy value in kilocalorie per mole unit that holds the protein ligand complex together. Based on the 9 modes of these complexes, there will only be one mode with the lowest energy binding value that qualifies to be compared at the end of this process. Docking results of bleomycin with 3CL Pro were tabulated in the following table 1.0. The first mode have the lowest binding energy value at negative 10.6 kilocalorie per mole, while the figure here shows the binding of 3CL Pro and bleomycin, at which the blue strands represent the 3CL Pro strands and the rainbow part is the bleomycin, which is the drug. Same goes to the mitramycin with the 3CL Pro, at which the blue strands represent the 3-chymotrypsin protease and the blue part is the mitramycin drug. The value is also the lowest at the mode 1, at which the value is negative 11.7 kilocalorie per mole. While for the docking of goserelin with 3CL Pro, the binding of energy is also the lowest at the first mode, at which the value is negative 11.2 kilocalorie per mole. The docking is also the same, whereby the blue color represents the 3-chymotrypsin-like protease strands and the rainbow is the ligand or the drugs. Based on the results shown, among all the 3 docking complexes, mitramycin is the most suitable drugs candidate as the binding energy values among other complexes. The value is at negative 11.7 kilocalorie per mole, which is lower than the other 2, which are negative 10.6 kilocalorie per mole and negative 11.2 kilocalorie per mole respectively for bleomycin and goserelin. Mitramycin fulfilled the criteria for the lowest energy for being the most suitable candidate to fight against 3CL Pro of COVID-19. And it shows that molecular docking methods can determine the most suitable drugs using Autodoc Vena, PyMol, and molecular viewers as the software to evaluate the energy value to be the best drug to treat COVID-19. However, experimental work is needed to be further conducted to really confirm the effectiveness of 3CL Pro and mitramycin dock complex on a large scale. These are the list of references that were used for my slide. If you have any question, you may ask in the Q&A session. Thank you.